Alright, so now we're going to get into sample problems. We need first to practice factoring. We need to be able to factor a quadratic, at least a fairly simple quadratic, before we can use it for some purpose. So let's start with 3 x squared plus 6x plus 5. Okay. So, as we said in the intro video, clearly it's going to be these two numbers we're going to fill in, and these two numbers are going to multiply together at some point during the distribution process. And when you multiply those two numbers together, what do we get but just a number? It's the only number that there is, just by itself, no variables. So it must be that these two numbers multiply together to make this guy here. And we also said they must add together to make this number here. So let's think of all the ways we could multiply to 5. 1 times 5. That makes 5. And that's it. There's only one way to multiply two integers together and get 5. 1 times 5. So hopefully 1 plus 5 will also make 6, and it does. So let's see, 1 and 5 multiplies to make 5, adds to make 6. Okay, let's just multiply those out and see, does that work? X times x is x squared. X times 5, it gives us our 5x. 1 times x gives us our 1x, and 1 times 5 will be the constant 5, so x squared plus 6x plus 5. So yeah, it worked out. Multiplies to make this number and adds to make this number. Let's do another one. We'll do number 5. Okay, it's a little bit different. It's a instead of x, but that shouldn't throw you off. You just use a instead of x. So we're looking to fill in these parentheses with some value here, such that, well, obviously we're going to multiply these two together, and when we multiply these two numbers together, we should get a number. And that's the only source of a number by itself with no variables, just this guy times that guy. So we need to make 22. That'll be 11 times 2, and 1 times 22. We could do that. That would make 22. All right. Okay, so we could try 1 and 22. Let's make it a little easier. Let's do 2 and 11. Okay, if we multiply these together, we get a squared. That's from there to there. And we get 11a, and then we get 2a, and then we get 22. So that is almost exactly what we need, except this is a positive 13a. It needs to be a negative 13a. So how could we make that work? If this were a negative 11 and this is a negative 2, then we have negative 13. Is that legal? Could we just go negative here, negative there, and we get negative 13? That means these would be negative. Yeah, and negative 2 times negative 11 also gives us positive 22. So whether these are both positive or both negative, we still get a positive when we multiply them. But depending on whether they're both positive or negative, we'll get a positive or a negative when we add together. So that's one of those things you have to think about as you're working these out. If you have a positive here when you multiply and a negative when you add, it must be that they're both negatives, right? Let's look at another possibility. What else could happen? Let's do number 7. P squared plus 2p plus 4. So we're looking to fill in these parentheses. They need these two numbers here that we're trying to find will multiply to make 4. So how many ways can we multiply to make 4? 2 times 2 could be 4. Okay. 1 times 4 could be 4. And that's it. We could try even negative 2 times negative 2, as we saw was that came up here. That made 4. Negative 1 times negative 4. But which one of these possibilities also adds to 2? That's what we needed to do. We needed to add to 2. 2 plus 2 is 4. 1 plus 4 is 5. Negative 2 plus negative 2, that's going to be negative 4. If we did negative 1 times negative 4, it'd also be positive 4 when you multiply, but they would add a negative 5. So there is just, these are all the possible ways we can multiply two numbers together and get positive 4, but none of them adds to 2, which it needs to do. So we just say can't be factored. And that's a possibility. Okay. So let's go on to the next little section here. And that would be, it says special patterns. Now I chose not to teach this outright because I think it'll be more handy later, and it just happens. I mean, you don't need to be taught that there's some special pattern and notice that there's going to be a special pattern. So let me show you what I mean. 15. So let's factor this exactly as we would, exactly as we have for the last 3 examples. Okay. The only thing here is that with these 3 examples, we had a middle term. We had a 6x, a negative 13a, a positive 2p. But here we just have an x squared, and we go straight to the constant. So in order for this to fit our, the way that we have been doing this, we need to have a middle term. So we'll put a 0 there, 0x minus 36. So we need 2 numbers that multiply to make negative 36 and add to make 0. So what 2 numbers could multiply to make negative 36? We could do 12 times negative 3. We could do 6 times negative 6. We could do negative 12 times positive 3. This would be negative 36. This would also be negative 36. We could do 4 times 9. 4 times negative 9. Or negative 4 times positive 9. Okay. The question is, when we fill this in, this is x, this is x, which of these combinations is going to add to make 0x? It's not going to be negative 4 and 9. That's going to make positive 5. This is going to be negative 5. This is going to make positive 9, negative 9. It's the case where they're both exactly the opposite. If this is positive 6 and this is negative 6, then when we distribute all this out, we'll get x squared minus 6x plus 6x minus 36, and these two cancel each other out, and we're just left with x squared minus 36. And you'll notice that they have to be exactly the same number, just opposite of each other, just one positive, one negative. And when they are exactly the same number, what you get is a perfect square, and x squared is a perfect square, and so what they call this is a difference of squares, because you subtract x squared minus 6 squared. Okay, recognizing that pattern at this point, I just don't think it's as helpful. So if you notice it, that's great. We'll study it more later on. But that's a difference of squares. Let's look at another special pattern that comes up, but it'll just be. It'll just happen. All right, so let's work on factoring this out. We need to fill in these 2 parentheses. This would be t, and these 2 numbers here are going to multiply to make 64 and add to make negative 16. So let's think about the numbers that could multiply to make 64. Do 8 times 8, and that's 64. We could do 4 times 16. We could do 2 times 32. We could do all these different possibilities, but something that you might notice is that this is positive, this is negative. We multiply to make positive, add to make negative, so that's a situation where both of these would be negative. Right, so that's how we should do it. So in which of these do we add to make negative 16? Right there, negative 8 and negative 8 will add to make negative 16. So we get t minus 8 and t minus 8. And that will, when we multiply it out, make this, this standard form. The thing about this is they are exactly the same. They are identical. This is t minus 8 times itself. So we could write it as t minus 8 squared. Okay, and that'll be useful later as we solve more complicated problems. But worry about it then. This is what we call a perfect square trinomial. It comes from a perfect square. You take this guy, you square it, you multiply it by itself, and this is the result. And this is a trinomial, and it comes from a perfect square, and that's why it's called a perfect square trinomial. Okay, so those are Those are those. Okay, so now the big question of why are we doing this? Why are we factoring these? And that's a great question. I'm glad you asked that question. And here is why. We factor quadratics so we can solve equations, quadratic equations, like 24. Okay. So what we're going to do first, first we're going to make sure it's equal to 0, and that's the genius of it. It's just, I don't know, when I think about it, I think of the first guy who thought of this, and the fact that it had never been done before, and the fact that they thought to do it this way is super clever. And you're just handed it like it's nothing, but it's awesome. So the first thing that we need to do is factor this side. So first we're going to make sure that this side is 0, and then we're going to factor this. Okay, and let's just assume we don't need more to practice factoring. I'll just go ahead and factor this really quick. I think really quick. Okay, so x minus 6 times x minus 2, this will multiply to make positive 12 and add to make negative 8. The cleverness, the genius of this, first of all, we'll kind of have to depart from this and look at a fairly obvious thing. What do you get when you take 0 times anything? It doesn't matter what it is. You get 0. Okay. Pretty clear. All right. What happens then? When you multiply two numbers, what if you don't know what these two numbers were? You just multiply two numbers together and you got 0. Well, definitely 0 times something would make 0. Is there any other way for that to happen? Could you multiply these two numbers together and get 0 and one of them not be 0? 1 times 2. No, that's not going to work. That's not going to make 0. 5 times 17. No, that's not possible to make 0 that way. The only way to multiply two numbers together and get 0 is if one of these, or possibly both of these, but at least one, absolutely has to be 0. So, we can make the statement, if a times b, if two numbers times each other equals 0, then either a equals 0, or b equals 0, or even possibly both. Okay, but not definitely both, so we don't really worry about the both. We're not worried about possibly. Guaranteed, though, that A is 0 or B is 0. One of them has to be 0. There's just no way for these two numbers to multiply and make 0. And that's the situation, the genius, that we've set up over here. We've taken a number, this number in the parentheses, times another number in the parentheses, and shown that those two multiplied make 0. What does that mean? Either this one is 0 or this one is 0. Either x minus 6 is 0, or, should be the word or there, x minus 2 has to be 0. Has to be. One of these has to be. Okay? So that narrows it down to there's only two possibilities for x. If we solve for x here, we find out x could be 6 or x could be 2. Those are the only solutions for this equation. That's it. If you put 6 in here, you'll get 0. 0 times whatever this is 0. If you put 2 in here, even when you put 2 in here, which you need to do when you're making x2, 2 minus 2 will be 0. 0 times this will be negative 4. But it doesn't matter, because 0 times anything is 0. So, just if you're ever not impressed by something, think about the fact that at some point in mathematical history, this didn't exist. This approach did not exist. And somebody, someday, once upon a time, thought, I'm going to try this out. And it's genius. It works every time. It uses a previously established law that, hey, two numbers times each other equals 0 means one of them has to be 0. It's just great. I could go on and on and on. But I'd probably just repeat myself, and that wouldn't be very convincing. So, let's try again. Number 26. X squared plus 2x minus 35 equals 0. Okay, it already equals 0. That's great, because you know what we're going to do? We're going to take this guy here. We're going to factor it. Factoring means, a factor is something that's multiplied. Right? Like 15, factors of 15 are 3 and 5, because 3 times 5 is 15. That's how we know they're factors. So we're going to factor this. That means we're going to put them in parentheses that are multiplied together, and that also will be equal to 0. And the genius of it is that either this parentheses has to be 0 or this one has to be 0 because we're multiplying them together and they equal 0. Just awesome. So factor, that's the important thing. Factor it, two things multiply to make 0. That's the key. So x and x, they multiply to make negative 35. Add to make 2. They multiply to make a negative. That means one of them has to be positive, one of them has to be negative. Let's make 35 and add to make 2, so like 7 and negative 5. 7 times negative 5 is negative 35, and 7 minus 5 is 2. So there you go. Genius right here. One of these parentheses, one of these numbers has to be equal to 0. Because when you multiply them together, you get 0, and there's no way for that to happen unless one of these things is 0. So either x plus 7 equals 0, or x minus 5 equals 0. So x equals negative 7, x equals 5, negative 7 and 5, both valid solutions to this equation. Either one plugged in for x will give you a 0. Try it for yourself, and you won't be disappointed. Alright. Okay, let's add a slight curveball in there. We will do number 34. R squared plus 2r equals 80. What's the slight curveball here? Typically, we just take the stuff with r in it, or this may be a way that our brain has been wired as we've been learning this. Factor it, and then set each of those equal to what you see over here. But remember the genius. The genius is that when we factor it, it's equal to 0. When we factor whatever we see here, the factored part, the factored form, or the two things being multiplied, have to equal 0. Right? If we left it be 80 over here, there's no implication about two things multiplying to 80. There's lots and lots of ways to multiply to make 80, but there's only one possibility, or there is a definite conclusion we can make about two numbers multiplied together making 0. One of them has to be 0. So we've got to get it to be equal to 0 first. R squared plus 2r minus 80. Got to subtract 80 on both sides so that this side is 0. Get everything on one side and 0 on the other. So you subtract 80 on both sides, and there you go. So we need to multiply to make negative 80. That means a positive and a negative, and add to make 2. So looks like 10, positive 10, and negative 8. That'll add to 2 and multiply to negative 80. And there's the genius part. Either r plus 10 is equal to 0, or r minus 8 is equal to 0. The only possible conclusion we can make is that one of them has to be 0. So either r is negative 10 or r is positive 8. Okay? Just great. It's fantastic. Number 44, the first of this kind, finding zeros. Okay, what does it mean to find a 0? Let's write down. Now this is, when we have this y in there, we start to call these functions. And let me show you. Show you why. Because now that we have an x and a y, two different variables, x we call the input, y we call the output. There's this input and output, and we talked about functions before. If there is no equals y, if it equals 2 or 0 or 3 or whatever, then it's set. The output of this is set to whatever number this is. Now this is a variable. This could be anything. This is a function. Okay, put things in, get things out. Anything you want in, because anything goes in this kind of a function. You can square any number and multiply any number by 6, so there's no restrictions. No restrictions on the domain. And then the output can be pretty much anything. There are limits on what you can get out of this function. So what we want to find are the zeros. The zeros of a function are, first of all, it has to be stated this way: y or f of x or g of x or something. The name of the function has to be over here, equals stuff with x in it. right? So just y or f of x, nothing else, just on this side. And then on this side is your x stuff and any other constants you might have. The zeros of this function are what can you put into the x, and of course the same thing, if I put 1 here, I have to put 1 here. So what can I put into this function that will cause the output to be 0? That's the question. That's what a 0 is. So it's pretty clear that if we want to find that out, all we have to do is say, well, let's make y 0 and then solve for x, find out what x would have to be. So now we're just solving this equation. This is just like the types of equations or types of problems just before these ones that we did in this video, is solving this equation for x. So we just factor, right? So we are looking for two numbers that multiply to 8 and add to 6. Filling this guy in, be 2 and 4. I think we all saw that one coming. And so again, the genius part of it is that two numbers, or any number of numbers, it could be 3, 4, 5, 17, whatever, all multiplied together equals 0, means one of them has to be 0. So either x plus 2 equals 0, or x plus 4 equals 0. So x could be -2. If you put -2 into this function, it will give you a 0. Or x could be -4. You could put -4 into this function, and it will give you 0. Okay? And now that makes sense. Think about graphing this guy. If we graph this function, it's going to be a parabola. Okay? So let's just graph it really quick. So a parabola is going to, open up or open down or whatever. And where do we get an output of 0? Where is y 0? This is the y-axis, positive y here, negative y here. So 0 y here. All along the x-axis, you'll find zeros for y. Y is 0 along there. So at -2 and at -4, you're going to find zeros of this function. All right. Now we also know that, let's see, 8 is on here. 3, 6, 7, 8, 0, comma 8, right? If we put a 0 in for x, we'll just be left with 8. And so symmetry tells us that we'll go this far over here. And so this gives us an idea of where we should be drawing our graph. Okay, so this graph will cross the x-axis, or be worth 0. The output will be worth 0 at -2 and -4. Okay, and so the thing that we learned from the graph, is kind of a little bit more of an intuition that there's only two solutions, this one and no more. There are no more numbers that you can put in for x that will give you a 0. Okay, let's do one more like that where we find the zeros. Maybe two more. Maybe two more. So f of x equals x squared plus 11x. Okay. So we're going to find the zeros. That means we want to find out what can we put in for x. This is the question. What goes in there for x in order for 0 to come out? So let's just make the output, lock that in, make it a 0, and then figure out what x would have to be. And if we're going to factor this, we should really write it as, in the form ax squared plus bx plus c. What is c? There's nothing there. It's 0. So 0. So now we're going to factor this. We got 0 equals, so we need a number that multiplies to 0 and adds to 11. This is a really easy one. We could just fill this in. What multiplies to 0? Well, one of those numbers has to be 0. That's something we're learning now. And it adds to be positive 11, so we'll have a positive 11. So 11 times 0 is 0, and 0 plus 11 is positive 11. So again, genius. Number times a number is 0, so either this number is 0, or this number is 0. So x is -11, or x is 0, both solutions. If you put a 0 in here, or you put a -11 in here, you'll get 0 as the output. And then number 52, That'd be the last of the zero finding ones. F of x equals x squared minus 12x minus 45. So again, what can we put in for x to give us 0 as the output? Let's just make the output 0 and then solve for x. We got to factor this. Two numbers that multiply to make 45, negative 45. If we're going to multiply to make a negative, we need a positive and a negative to multiply together. And they add to make negative 12. So how about 15 and 3? 15 times 3 is 45, and 3 minus 15 is negative 12. Positives and negatives all working out, so either x plus 3 is 0, or x minus 15 is the 0. It has to be the case. So x is negative 3, or x is positive 15. Either one of those will work when you plug them in. They're both solutions. Okay. 66. A rectangular, so let's draw a rectangle. A rectangular zoo is, oh, okay. A rectangular enclosure at a zoo, because it's 35. I'm laughing because it's 35 by 18, and that would be a pathetically small zoo. But if it was just an enclosure for a single animal, still pretty small. But it makes more sense than the entire zoo. So it's 35 feet by 18 feet. All right, so what? Great. We know everything about that we could possibly know. The zoo wants to double the area of the enclosure by adding the same distance x to the length and the width. So try and get a picture in your mind of what's going on here. What are they physically going to do? What are they actually going to do to this enclosure? They're going to add a little bit to this side, add a little bit to this side. The thing about those little bits, okay, this is going to become a larger rectangle, and they want it to be twice the area. Zoo. The thing about those little bits that they're going to put on to this, the width and the length, is that they're going to be the same amount, right? This side is going to be now 18 plus a little bit more, plus that x. And this side's going to be now 35 plus a little bit more. And that little bit more is going to be the same for both of these. Okay, they want to double the area now. They want to double the area of the enclosure. So that's something solid, something that we know. We know that if we take the area of the original enclosure and double it, that's the area of the new enclosure. So how do we find the area of the old enclosure? You should know it should be pretty at hand, right there in your mind, easily accessed, that length times width, or width times length, or whatever order. That's the definition of area. And we're going to double this. So we're going to double this area. Okay. So that number is going to be the total area of the new enclosure. And how would we, if we knew x, how would we find the area of the new enclosure? Well, it'd just be the length and the width. Length times the width of the new enclosure. So here's the length of the new enclosure times the width of the new enclosure. So this is a representation of the new area, and this is a representation of the new area. And now we just need to solve for x. What values of x are going to make this happen for the zoo? Okay. Let's see. It's going to be... I'm not even going to pretend I can do that stuff in my head. Let me just grab my calculator. Wherever it is. Well, let's just grab the calculator here. Why not? And we will turn it on. Get out of there. 18 times 35 times 2. Great, that's 1260. 35 times 18. We're going to multiply these things out. 35 times 18 is going to be 630. Okay, I don't think we need that calculator anymore. Right, this times this is 630. Then we're going to get 35x, and then we'll get plus 18x plus x squared. So we have 1260 is equal to 630 plus, let's see, 40, 53x plus x squared. I'm just going to rewrite this a little bit. I like it to be written in order. X squared plus 53x plus 630 equals 1260. All right, so look what we have here. We have a quadratic equation, and we know that in this section at least we're going to solve this by factoring. But we just talked about the genius of solving by factoring, and that is that it's equal to 0. So we got to get it equal to 0 first. X squared plus 53x. Let's just subtract 1260 on both sides, so 630 minus 1260 is negative 630. So we have a negative 630 because we subtracted 1260 from both sides, so that we would have 0 over here. All right, so we need two numbers that multiply to make negative 630 and add to make positive 53. That's, wow, okay. So let's work on it. 630 divided by, let's say, 10. That was pretty genius because we know, or that was lucky, I guess. X and X, we're trying to fill in these parentheses as we factor this quadratic. We want to multiply to make negative 630 and add to make positive 53, and we just found that 10 times 63 is 630. So how about if we make this a negative 10 and a positive 63? Okay. Then if you multiply this out, you will find it's exactly the same as this, right? We're going to multiply and get negative 630, add to get positive 53. So there you go. The genius part of it, right? You multiply these two parentheses together, you get 0. Which means that either this is 0 or this is 0. So x could be 10 or x could be negative 63. Now in the context of a real-world problem, which of these solutions actually makes sense? Are we going to add on 10 feet to both length and width? Or are we going to, hire a contractor to maybe pour some concrete or move a fence and say move it negative 63 feet? No, that doesn't make any sense, right? It doesn't make any sense at all. So no, this is no good. This is a nonsense answer, and this real world problem, adding on 10 feet to both sides makes more sense. And so this would be what we would do: add 10 feet onto both sides. Okay, so thanks for watching. Hope that was helpful.